I'm going to share my screen. Okay. Let me see. Give me a second here. All right. So if you can see the screen, say yes in the chat. If you cannot, say no. All right. So it seems that you can see the screen. That's good. So today, let's just start with the homework or some review questions. Okay. So we learned about how to factor last time. So we need to make sure that we can factor well, because today we will be using the factoring to solve some equations. All right, so let's just start with this first problem here. All right, so hopefully everybody has gotten a chance to solve this. Okay, so first we need to, factor out what we can, right? So can we factor out any, numbers right now? It seems that we cannot, right? We cannot factor out 7 from 45, but we can factor out 28, but it doesn't really matter. Okay, so we can just start with our method here. So we need to find the factors of 7 and the factors of 28. Okay, so let's find the factors of 7 first. Let's just say 1 and 7 here, and the factors of 28. So let's just put maybe 7 and 4 here. And of course, one of them has to be negative. So what we need to do is we need to have, when we cross multiply these, they need to add up to the b term, which is negative 45, right? So currently we have 49 minus 4, which is equal to just 45. So it seems that we accidentally switched one of the signs here. So let's put the negative on the 7. So you see 7 times negative 7 plus 1 times 4, and that is indeed equal to negative 45, which is our B term. Okay, so now we can just go horizontally, right? So now we have the x minus 7, okay? As you can see, the colors here. X minus 7 like this, okay? And then 7x plus 4 like that, right? And that's how we factor. So it's a pretty efficient way. If you practice a lot, then you can kind of tell which ones are going to be the factors and which ones are not going to be the factors. And once you are familiar with it, you can even do it in your head. So hopefully everybody did not completely forget how to factor last week because I was sick and we did not have a class. But we need to, review a little bit. Okay. All right. All right. So let's see. Okay. So what we need to do here is, again, we cannot just factor normally. Okay. What is this form? It's ax squared plus bx plus c. And our a term, right, is greater than 1. So it's not 1 or 0. So that means we have to, do this the same method as last problem. So we find the factors of 9, find the factors of 10, and then hopefully they work out, right? So let's see what happens here. We could do that, but that doesn't seem to be it. Yeah, 6 minus 15. Okay, I don't know how we're gonna get that. Um, let's see here. We could try just 1 and 10, but that will probably not work either. So, I don't know. Let's see. 1, 9 here, and then 2, 5. Obviously, that does not work. Good 1, 10 here. Again, not working. So I'm starting to wonder if this actually is factorable. So let me check real quick. Does anybody else have any ideas while I'm checking right now? Okay, yeah, just as I thought. Apparently this is not factorable with real numbers. Huh. Okay, let's change the problem a little bit then. Let's change the problem a little bit. Hopefully we can, find something that factors. Let me see. What if we change this to maybe you change this to, -9. If our b term becomes -9, then we can probably factor this, right? We can have 3, 3, then 2, 5. We can have -5 here. Okay, so then 3 times -5 plus 3 times 2 is -9. Okay, so that would be, factorable. Okay, so 9r squared minus 9r minus 10. Apparently that was not factorable with rational numbers. Probably made a mistake copying the question down or something. But this is actually factorable, so we can practice with this. Once you find the correct factors, you can check. Obviously 3 times -5 plus 3 times 2 is equal to what? It's -9, right? Right. So then you simply have 3x plus 2 and then 3x minus 5, right? All right, and once you factor, you should never make a mistake while factoring. Should never. Because you can always check your answer. So once you factor something, multiply it back out. If it works, then you did it correct, right? If it does not work, then you probably made a mistake somewhere. So you should never really turn in an incorrect factorization because you can always check your work pretty easily. Factorization is essentially the opposite of distributive property, and you know how to distribute, how to multiply this out, right? So if I multiply this out, okay, let's see what I need to do. I need to multiply 3x to 3x, 3x to -5, and then I need to multiply 2 to 3x and 2 to -5. So let's see what we get. When I multiply everything out, I get 9. Actually, this is not x, this is r. Yeah, because the problem says r, so we use r. So this is equal to 9r squared. That's 3r times 3r. And then we're gonna times, negative 15r plus 6r. Okay. And that's minus 10 here, and that's gonna be equal to 9r squared minus 9r minus 10, and that's exactly what we started with. And if we multiply it back out and we get what we started with, then that is the correct factorization. That's how you check your work. All right, so always make sure that you can check your work. All right. Okay. So, Let's do this next problem here. All right, let's do this one. So this one, okay, apparently this copied wrong. This is supposed to be 3b cubed. So well, that's fine. We can do the same thing. So just factor out a b. 3b squared minus 5b plus 2. The b can just stay on the outside. We don't care about it. Just add it, just let's just worry about the inside for now because that's what we really need to factor. Again, because our a term, again, we're in the, ax squared plus bx plus c, where the a term is not 1 or 0, we have to use this method here. We need to find the factors of a, 1 and 3, let's say, and then we need to find the factors of 2, the c term, so 1 and 2, okay? So then what we get is, add a negative to this. Then we get 3 times -1 plus 1 times -2, which is equal to -5. Those are the correct factors. We get b minus 1 times 3b minus 2. All right? And that is how you factor. So are there any questions before I move on? Any questions? I think most people should be fine on this. It's not that comprehensive. you just need to know, you just have to be proficient at finding the factors that work. It's not too complicated of a concept. I think you can grasp it. This is what, okay, so this was just some review from last time. Okay, so let me go over the strategy again. Okay. So this you use when the form is ax squared plus bx plus c. Okay. And you look at the a term and the c term. Okay. And now you have to find the factors of a, the factors of c on this side. Okay, draw an x here. The factors of a, let's say a1, a2, okay, c1, c2, such that, a1, c2 plus a2, c1 is equal to b. Okay, this term here. And then, ax squared plus bx plus c is just going to be equal to a1x plus c1 times a2x plus c2, like that. So that, of course, seems a little bit abstract, right? But that's fine. Let's just go over, some more examples. Okay, so using the same method, you can, find some problem here. Actually, let me explain the first problem again using this thing. Okay, so this thing here, so 7x squared minus 45x plus 28, right? Is it? Okay, it's minus 28, that's why. Minus 28. Okay, so we need to look at a. All right, so I think we took up too much space here. Let me just rewrite all of this information more compact so we have a little bit more space for the example. So I'll keep it up here. So if you're not done taking notes yet, I'll rewrite it again. So you need to find a1, a2, which are factors of a, c1, c2, such that a1, c2 plus a2, c1 is equal to b, and then ax squared plus bx plus c is going to be equal to a1x plus c1, and then a2x plus c2. Okay, that's our little, box of information there, what we need to do. So let's just go back to our example here. So here, our a term is 7, b is equal to negative 45, c is equal to negative 28. Sometimes it's good to list out these things here. Okay. So we need to find the factors of a. You only have, what, 1 and 7 for a. Okay. So draw the x. Let's just put, factors of 7 here, factors of negative 28 here. All right. So we only have 1 and 7 as, as an option. Okay, but for 28, we have more options. You can do like 2 times 14, 4 times 7. Again, as I told you last time, find the factors that are
这个
closest to
6K 还 unlimited.
Huh?
This is brilliant.
What did you say? Who is unmuted right now? Did you say something?
It's hard to use Zoom on a phone.
Okay. Anyways, um,
Put your camera on. I will do it. Not on.
are you trying to say something, or is your mic just unmuted
Oh,
unintentionally? Okay. Thank you very much. Okay, so we need to find the factors that are closest together, which are 4 and 7, right? 4 and 7, we're always going to start with 4 and 7. If 4 and 7 doesn't work, we're going to go to, 2 and 14. Okay, but we always start with the factors that are closest together.
it's
They're most
already
likely to
I wanna look.
they're most likely to work. All right.
The floor 你個 door open。
So now we have let's say 7 here and we have 4 here. Okay, so these now we have the factors. Okay.
佢哋嗰個嚟幫手整，唔使叫人咩？
Okay, who is unmuted again? Are you trying to say something? Okay.
Could you move? You have to tie seatbelt. We're going the highway. Not going anywhere, okay? We're just going to the highway. If you were saying how to make please. I don't know what. Don't like it.
Who is unmuted right now? Okay, please do not just unmute yourself and
Alright,
say-
I'm on my phone right now because I need to go traveling and yeah. And it's hard to like I never used Zoom on a phone before, so I don't know how to turn off my mic and turn on.
Okay, I see how it is. That's fine. Just make sure there's not too much background noise. All right,
Okay.
thank you. Let's continue here.
Like-
So we need to, again, as I was saying, we have 7 and 4 here, but of course we have negative 28. So one of them has to be negative. Let's just say 7 times negative 7 and then 1 times 4. Okay. So you have to make sure that 1 times 4 plus 7 times negative 7 is equal to negative 45, which it is. All right. So these are the correct factors, and thus we have x minus 7 and then 7x plus 4. That's the big idea of this more advanced factoring concept. All right, and again, last step, make sure you can check your answer. I'm not going to right now for the sake of time, but if you're doing homework or anything else for a class, make sure you check your answer, because if you check your answer, you can always get it right. All right, if you check your answer and you don't get what you started with, okay, maybe you made a mistake. But if you get check your answer and you get exactly what you started with, that means you factorized correctly, and you will turn in the correct answer. So checking your answer, very important. If you're unsure, of course. Me, I've done it for like a lot of years, so I probably don't need to check. It just sort of looks correct. But if you just started learning and you don't really know how to factor yet, please do check your answer. Okay. So now we can do factoring by grouping. So let me find an example. Factoring by grouping. I mean, let me just give me a second here. It's easier to teach with example with numbers. All right, so let's just use this one, x cubed plus 3x squared plus 2x plus 6. So of course, factoring with grouping, you need to group them into two groups. So usually the higher degree ones into one group, lower degree ones into one group. The point is you need to factor these separately. So we factor out x squared in the first one, we get x squared times x plus 3. Factor out 2 in the latter one, we get to 2 times x plus 3. And the point is, with factoring by grouping, we want to get this. We want to get the similar factor between these two groups here, x plus 3, then thus we can get x plus 3 times x squared plus 2, right? That is how you factor by grouping. It is a pretty simple compared to this one, right? Factoring by grouping is what we talked about last time. So all of these we have talked about last time, just refreshing your memory because we did not have class last week. I don't know if you still remember everything, right? Okay, so now I can introduce you to quadratics. Quadratic equations basically is an equation arranged in the standard form ax squared plus bx plus c is equal to 0, where x is a variable and a, b, c are real numbers. Of course, a does not equal to 0. All right, so you only know how to solve, equations with maybe, 4x plus 2 is equal to 8. You know how to solve that, right? Answer is 3/2. Okay, but what if, there's x squared here? What happens then, right? So, we don't know how to solve those, okay? Now we can solve quadratics with factoring, now that we know how to factor. So I'm going to teach you how to solve these, equations with x squared in them with factoring today. So quadratics, basically anything that has x squared in it. Okay, so like x squared plus 3x plus 4 is equal to 0. All right, x squared minus 5 is equal to 4x. Okay, this quadratic. The key point from the slide, make sure you remember this, is that to even begin solving a quadratic, you have to make sure that the right-hand side is 0. You have to make sure that the right-hand side is 0, all right, always. Okay, key point here. Let me just write it down for you guys. All right, key point. Make sure the right-hand side is 0. It doesn't have to be right-hand side, actually. It could be any side. Just make sure that there's a 0 at the end, and everything else is on, isolated. Okay, so 0 is by itself. And why do we need 0 by itself? Great question. I'm going to explain into, on the next slide. Why we need specifically 0 on the next slide. And I can explain this with the 0 product property. So having 0 is so useful, right? What is anything times 0? 3 times 0 is what? 0. 5 times 0 is 0. 6 times 0 is 0. You get the point, right? 1,000,000 times 0 is still 0. We can take advantage of that. If you have two things, all right? If you have two things, 6 times x is equal to 0, one of them has to be 0. Just so happens that x is equal to 0. That's how you solve, right? I mean, you can definitely solve this type of problem, right? If you have two things, one of them has to be 0, all right? Because once one of them is 0, it doesn't matter what the other one is. The whole equation is going to be equal to 0. So maybe you have x, maybe you have x times y is equal to 0. Either x is 0, y is 0. Okay, let me just change this. Either x is equal to 0, y is equal to 0, or both equal to 0. And this is true for how many ever, x's and y's here. So you got a1 times a2 times a3 all the way to an is equal to 0. Then either a1 equal to 0, a2 equal to 0, a3 equal to 0, an equal to 0, or any combination. Because we don't care about anything else. As long as one of them is equal to 0, the whole thing is equal to 0. Okay? So how can we actually apply this? Now that we know, I mean, it seems pretty common sense, right? Even if I didn't tell you about 0 product property, you already know it because you know that anything times 0 is equal to 0. So how can you actually apply this to quadratic equations? Okay. So that's with the next slide. Okay. So how about let's just go back to this, first example here. 7x minus 45x minus 28. Okay. So, and we know the factored form is going to be equal to what? X minus 7, 7x plus 4. Last time I check. Yes, that is the correct factorization. So let's go back here. All right, we know that this factorization. Okay, so now let's solve the quadratic form. Let's set both to equal to 0. All right. So how do we solve it when it's equal to 0? By the zero product property rule, we get 7 minus x minus 7 is equal to 0, or 7x plus 4 is equal to 0. So what do we get here? X is equal to 7 from this equation, and what? X is equal to negative 4 over 7 from this equation. That's what we get. And notice how this quadratic equation, it's x squared, meaning it's degree 2, right? It's degree 2. And when we have degree 2, we have the same amount of answers as the degree. So if you have a quadratic equation, you should have at most the nth degree amount of answers. So since we have a quadratic here, we're going to get at most 2 answers. All right, so does everybody understand that when you, take the factors and you set them to 0, either one of the factors is equal to 0 or the other one is equal to 0, or, both is equal to 0, and thus we get 2 different answers, all right? You should not be getting one answer, or actually, you can get one answer in some special occasions, but usually you will get, for these types of problems, you will get 2 answers, or at most 2 answers, okay. Okay, how did I get x minus 7? This is just from this slide. I just copied this factorization and copied it over. Okay, so I didn't really explain the factorization on this slide because it's already a given, just to facilitate the explanation a little bit. But do you understand on the other slide how I would get the x minus 7? You know how to factor? Or did you have trouble understanding the factoring? Okay, if there are no questions, then I'm just going to keep going here. And let's go to some practice problems. So you need to factor this first. Make sure it's equal to 0. The factor is equal to 0. Factor it first and then find the answers. So I'm going to give you, since this is a new concept, I'm going to give you a little bit more time. Wrap your mind around it. Okay.
出嚟望下嗰啲有冇樣。
Okay, I forgot I was muted. So, let me just explain this one more time. So we need to move everything to one side, and then we factored it. Okay, we get n plus 3, and then 3n plus 7, right? It's nothing too new. We've talked about this before with our, factoring thing. Okay, so find the factors of 3, factors of 21. Make sure cross multiplying them, they add up to 16. And then use the zero product property. We get m plus 3 is equal to 0, 3m plus 7 is equal to 0, and thus we get m is equal to -3 and -7/3. Okay. Any questions about this? If there are no questions, then I think that is all for today. We will talk about more about, solving these quadratic equations next time. So, make sure you do the homework for today. And then see you next time. So thank you very much for coming.
All right, thanks.
All right, thank you. Goodbye.